So if you observe the motion for the block A, so suppose you observe the block A from the frame of reference of the block B. Okay, then you will observe as the block A is moving towards the left side compared to the motion of the block B. And therefore, the impending motion for the block A compared with the block B, it is towards the left side. So this is the impending motion for the block A. So as the impending motion is towards the left side, that means the friction force will be towards the right side. Okay, and this friction force will be offered by the block B to the block A. Okay, and this value will be F is equal to, this is mu s into normal reaction, that is N2. Okay, so this is equal to 0.3 into N2. So at this contact surface, we have the same friction force for the block B and the block A. So you can observe here, this is 0.3 into N2, and this is also 0.3 into N2. Only direction is opposite. Okay, and the remaining force is the tension in this cable. So this is the T. So this is the tension vector. This tension vector, it is having some inclination. So let us take this inclination as a theta. So we can calculate this theta by using this dimension 3 and 4. So we will use theta is equal to tan inverse 3 by 4. So we can find out this value. So this is equal to 36.87. Okay. So now you can use the conditions of equilibrium for block A and for block B. Okay. So we have to consider the block A first, and then we can go for the block B. So what is the reason? If you observe the free body diagram for the block A, then in this free body diagram, we have tension T as unknown, and the second is the unknown is normal reaction N2. Okay. So in this FBD, we only have the two unknowns. And if you compare the free body diagram for the block B, then in this FBD, we have N2 unknown, N1 unknown, and force P is the unknown. So we have three unknowns. And for this problem, we only use two equations. One is summation Fx0 and second is the summation Fy0. Okay. We cannot use the summation of moment 0 because there is no tendency to rotate in this problem. Okay. So therefore, consider the block A first and use the conditions of equilibrium. So first condition is summation Fx0. So for summation Fx0, you can resolve the tension T in the X and Y direction. So this is the Y component and this is the X component. So in the summation Fx, we have T cos, this is minus because in the negative X side, 36.87, then plus 0.3 N2, that is a friction force. So this is that friction force 0.3 N2. Okay. So we only have two forces for summation Fx. This is equal to 0. For summation Fy is equal to 0. We have Wa. So this is minus 500 Newton. Then normal reaction N2. So plus N2 and plus the Y component of tension. So plus T sine 36.87. This is equal to 0. So we can write this equation in this form. So first is the tension T sine 36.87. Then plus N2 is equal to 500. This is the second equation and this is your first equation. So solve these two equations simultaneously and get the value of tension and the normal reaction N2. Okay. And then go for the second free body diagram. That is the object B. Okay. Use the same condition summation Fx0 and summation Fy0. So in this FBD, there will be unknown N1 and second unknown will be force P. Okay. And get the value of force P. So you can solve this problem. So try to complete this as a homework. Okay, so you can note down next problem. In this problem, the weight W1 and W2 are connected by a string. So string is passing over a smooth pulley. The coefficient of friction is 0.3 for all contact surfaces. Question is find the ratio W1 W1 by W2 required to maintain the equilibrium. Okay, so W1 is not given, even W2 is not given. So we have to find out what should be this ratio W1 and W2 so that the given equilibrium will be maintained. Okay, and the coefficient of static friction is 0.3 for all the contact surfaces. So when you solve any problem of the friction, you have to observe the impending motion. Okay, so can you tell me what is the impending motion for this system? Is it on this side, or for W1 it is on the right side, and for W2 it is on the downward direction along the plane? Which is the correct direction? To find out this W1 and W2 for the equilibrium, the correct impending motion is, if there is a possibility of motion, that means if the W2 it starts moving, then it will move in the downward direction. So this is the possible motion. So as the W2 its motion is downward, that means it will pull the W1 towards the right side. Okay, so in the free body diagram, suppose this is the W1, then its impending motion is towards the right. For W2, so this is the W2 along the plane, its impending motion is towards downward direction along the plane. Okay, so this is the W2. So in the free body diagram for W1, consider the perpendicular line as a y-axis, and this is the x-axis. Okay, and for W2, consider this is y-axis, that is the line perpendicular to this inclined plane, and along the plane as a x-axis.